Is anybody else impressed by how big this is? It's like kind of the biggest LED screen I've ever seen in my life. There's got to be thousands of pixels in here. We're going to make this a little bit interactive because I know you are all probably a little bit tired. I see a lot of people on their phones. You're not going to want to miss this content. This is probably more helpful than anything you've experienced in blockchain so far. To give you some context, I spent about 8 years developing hard technologies. So I designed router firmware for a while, built a mesh Wi-Fi network that covered an entire city, designed robotics systems for a while. Then I got into blockchain and I actually built a crypto school in Chicago. My name is Alex, by the way, or Al, you can call me. It looks like I might be doing this without the presentation, but we'll have some fun with it. We're just gonna quickly fill the room back up with some of these people. If you haven't met me before, many people will know that I'm a little bit crazy. Also, lo siento for the people who speak Spanish. I don't speak that much Spanish. I'm from Canada, but we'll get into that in a moment. One sec. Hey, you guys. Hey guys, do you want to see a really cool presentation? It's going to be very fun. You're going to learn a lot. I promise it will not be boring at all. We're going to do an interactive problem-solving process to teach you how to build the new internet. The real one. Not this thing that we're calling Web3, but the one that's going to come after it. You want to try some of that out? No, it's actually Web3. We're just going to actually build it now. Any of these people out here? Any of those people downstairs? Oh, well. You know, we tried. They're going to hear it halfway through, and they'll come back. We'll have a good time with it. Okay, so decentralization, a brief history. That's the title of this talk. It's not really, I don't know. We're not really going to do that so much. Wow, this is really flashing on me. You know, we can probably just do this off the top of the head. I think it might be a good idea to just unplug this. What? Maybe? Is it just the cable, maybe? Yeah, give it a shot. Go for it. While we're waiting for him to try and figure that out, we might not need it after all. The question I have for all of you, and we're going to make this, like I said, an interactive one. So just to get started, I want everybody to practice raising your hand above your head. Can we all do this? Yeah, we're not going to start the presentation until everybody puts their hand up in the air. So the rest of these people are going to get really tired if you don't put your hand up, sir, with the privacy hat. Secret is a great company. We love Secret. Okay, cool. Everybody practiced hand raising. Cool, this is good. Okay, so the first question I have for all of you is, why are you here? Why are we here? Is anybody here because they really like Bitcoin? No? Oh, this guy. Yeah, Secret Network. Of course, you guys all love Bitcoin. I love Bitcoin too. Bitcoin was the OG. We need Bitcoin. Who is here because they want to make money? We got some timeshares we're going to sell if you're into that. We're going to make you guys a lot of cash. No, none of that. Okay, DAOs. You guys like DAOs? DAOs are cool, right? DAOs are sweet. Okay, so what about maybe trying to fix corruption around the world? Does that matter to anybody here? We see some nods. This is good. Cool, cool. Who here, by the way, I told you guys, robotics, mesh Wi-Fi networks. I'm a big nerd. Who else is a big nerd? Anybody? Okay, big nerds. Cool, we got some big nerds here too. Yeah, nice. Who's really into smart contracts? Yeah, a couple people. Okay, yeah, so this is actually the problem. Nobody's into smart contracts. In the whole world right now, there are 13 million JavaScript developers. There's only 20,000 people that can write Solidity. That is an enormous problem if we're going to build a new internet. It's such a huge problem, in fact, that I have spent the last 5 years of my life trying to build another way to do this. And in fact, the way that I was planning to do it originally, which I had some lovely slides that we were going to show you that were going to make this really intuitive, but I'm going to try to explain it anyways. As a show of hands, does anybody know what Swarm is? From the Ethereum community? Yeah, we got a couple people. Okay, so Swarm, early on, Ethereum was actually a 3-part system, the world computer. It was Swarm, Whisper, and Ethereum. So Swarm was supposed to be a decentralized storage network, kind of like what we use now on IPFS and Filecoin, except that Ethereum was going to build it themselves. It's basically gone now. My old boss used to run that project. Anyways, so Whisper was the other component. Whisper was meant to be a decentralized communications network that would run on all of our devices all over the world. In your homes, it would pay you in crypto to use your devices so that we could build this decentralized internet, right? And then Ethereum was actually just supposed to be there so that it would allow you to process payments. That's what it was for. That's the whole reason that we built this blockchain thing. And that's actually because that's what Bitcoin was for, and that's where we came from with all this stuff. So the trick is, how do we build this decentralized internet thing? Oh, look at this. We have a thing. Okay, cool. So these are some fun slides. It's a little bit of historical context. When we talk about this stuff as a technology stack, it's actually really important to think about it in the broader context. So we're going to start with like 1000 BC. So in 1000 BC, they had early currency systems made of rocks that they got from islands. We'll talk about that in a sec, Yap Islands. They also had artist collectives that went way back to ancient Greece, where people were building sculptures and sharing revenues. And this was a gigantic way that they actually bootstrapped all of the early arts in a lot of these early nations. The Rand Institute in 1978 decided that they invented the word decentralization, and they wrote a fancy paper, and they made that graphic that you guys have all seen that's in all of the slide decks. Then Bitcoin came out because the US banking system crashed the global economy by lying to everybody and mismanaging all our money. That was a big deal. We all hate them. So we do kind of like Bitcoin. Finally then, Vitalik came along as the genius that he is and invented Ethereum, which was groundbreaking stuff because what he said was the consensus mechanisms we use for Bitcoin can also be used to coordinate information and data, which is really cool stuff. And then finally, recently I came along and invented this thing called Koi, but we'll do that very briefly at the end. And I'm not trying to put myself on par with any of these people. I just want to tell you guys about this thing because I have to do a little bit of that, otherwise I don't get to pay for my trip from the company. Anyway, so here's these big freaking rocks. These are cool. They used to go across to these, some people who've been in crypto have probably heard about this before. The Yap Islands in Indonesia had this really unique form of currency, which was that there was this one island that was like away from the rest of the islands, and it was made of these like really weird pieces of limestone. And so they would go over there, like a bunch of big guys who had a little bit of spare time, who were like kind of wealthy in the community, would, to prove their credit in the community, get on a boat, go like 6 days away, chip off one of these freaking huge rocks, put a hole in the middle of it, attach this hole. This hole is so they could connect it to their raft and bring it back to the island, and they put it in front of their house. And that's how the credit system worked. But it was decentralized because anybody could go and make credit by going and getting a raft and going to this island if you could get enough buddies together and get a rock. Pretty cool. They still have these. You can go to the Yap Islands. You can check them out. I haven't had a chance to go yet, but I'm really hoping to someday. Here's another really cool one. These are the tally sticks from England. This was how they did taxes for a really long time. These are pieces of wood. What they would do is they would take a piece of wood and they would make markings on it and they would split it in half. So you got to keep a copy and the tax collector kept a copy. That worked really well until the Tower of London burned down and all of the tally sticks went up in flames. So we need things that are immutable. It's really helpful. And also we need lots of copies of them, not just 2 copies, because that doesn't really work. Another really cool example is this artist collectives thing I mentioned. This goes way back to ancient Greece. It was how they made sculptures a lot of the time. You had to have a lot of people to make a sculpture, so you had to share the revenue from selling the sculpture. This was an early form of decentralization because it also included education. It was actually probably the first version of a DAO. And the reason I'm getting into all these weird examples is because in order to truly build the new internet and the new world that we want to live in, we have to think about it from a broader socioeconomic standpoint. We are all a bunch of nerds. That's why we come to these conferences and talk about technology all the time, and no one else cares at all. And if we want them to care, we have to think about all of the things that exist in the world that are like this and figure out how they got there. These ones got there by just including really passionate people and getting them going, and then those passionate people created really cool stuff that everybody else saw, and that got everybody else on board. And then people heard about it. So this particular one, this particular tiny little colony of people created works of art that are in every single gallery in North America, which is very cool. I'm sure that there are similar parallels in South America. I'm not that well read up on art, sorry. Like I said, technology person. This is that graphic that I said was gonna show up. This is the one that the Rand Institute claims is the original version. For those of you that may not be read up on this, centralized, everything goes through one point. Decentralized, lots of little sparkly things off on the sides. And then finally, a distributed network. So when we say that we're in here for decentralization, hello, long time no see. When we say that we're in this for decentralization, what we're talking about is actually one step in the process to get to a truly distributed world. Decentralization is not the end goal. It is actually a step in the process that we need to go through to get to a distributed economy, which is what we would really like to have. Distributed economies tend to work really well in small scales, but not in large scales, so we need a lot of innovation to get there right now. So, what is Bitcoin? Who here knows how Bitcoin works? Block creation, all that cool stuff. Remember we raised our hands at the beginning? Yeah, okay, we got 2 hands. 2 people in the room. You guys are the only ones that know how Bitcoin works? You know how Bitcoin works? Okay, we got 2. Awesome. So some people know how Bitcoin works. That's great news because otherwise this would be a really hard talk to get through. Vitalik came along and he was like, these block things, we can put data in them. This is really neat. We can add smart contracts. And here's Vitalik with a Lambo because he's pretty cool. So I mentioned this thing about Whisper and Swarm. We talked about that before while we were doing the little intro. And this is a post I found on Reddit from 5 years ago asking if they were dead yet. They are dead. Totally dead. Anyways, here is what this looks like now, which is pretty cool. So if you look at the whole system now, we've replaced the Ethereum paradigm because Charles Hoskinson and Gavin Wood decided they wanted to screw over their co-founder and they launched parallel competitors. And then some guys from Solana launched another one. And now there's a bunch of these things that kind of do transaction sequencing, and they all actually work pretty well, and you can use them all to do that. You kind of have lots of options now if you want to build really cool dApps. We also have a ton of storage networks. And these things are growing all the time. There's new ones coming out all the time. They're building on IPFS, some of them. And there's also a bunch of other ones. The thing that we're now missing is this last little piece, which is like, how do we connect all of you with your home computers to this network? Because that's what a distributed network looks like. You have to have a lot of devices talking to each other. Right now, these ones are kind of like on big server warehouses. And these ones cost so much to set up that the average person will never touch them. We're basically creating a new aristocracy of people who run nodes. That's not good. That is not what we set out to do with all this. That's just going to create a new banking system, which is going to look like 2008 again in like 30 years. So what we built at Koi, and this is kind of the plug that I mentioned, this is going to be educational, I promise. Mostly we're going to talk about technology and not about Koi. What we built at Koi is sort of a new paradigm that's designed to connect these things together. So there are 3 types of systems that you can audit, and you need systems that you can audit or you can't run them in a distributed way. Because if I can't trust that your computer does what I need it to, it cannot be a network where there's trust. So the first kind is these EVM type things where everything does exactly the job it's supposed to do. They're fully deterministic, and they have very, very limited flexibility. You can only do very small types of operations. The second kind is a fully verifiable language where you verify every line of code as it gets executed. These are extraordinarily expensive to run. They run at such a low capacity that you cannot do anything that you want to do on the internet. You can't even run a basic web app because the thing will crash. It'll crash your computer. It'll destroy the entire paradigm of computing, and we will waste so much electricity that we will probably run climate change up way faster than it's currently going. So the final one is what we're kind of working on. This is this idea of a bespoke proof framework. So a bespoke proof framework means we allow you to design your own consensus mechanisms, and you can implement little tiny audits along the way. So instead of every line of code being audited or the whole machine being deterministic, you choose which line of code you want to audit, and then you write the code that way. And we're working on templates for these because it turns out that within the realm of computing, there are only so many different types of audits that you actually can write and so many different types of proofs. And the best part is, since 2017, when everybody started shilling shitcoins, there are a ton of people who spent a lot of money designing all these proof libraries, and we can just grab them off of GitHub and use them. So it's really, really easy to get into this stuff. So what are tasks? This is this thing that we made up. They have an executable and an audit, and then we have a bunch of these nodes with reputation and collateral. We have 45,000 of them signed up right now to use our home computers. We just made a deal with IBM so that we can upgrade you if you do a good job and give you a cloud server for free based on credit, because we know that you're going to do a good job because you've already been doing it. So here is a gigantic graphic that explains how that works. It's very complicated. The very quick version of this, though, you write this executable file, you put it onto Filecoin, Arweave, something like that, and then you register it. And you say, I want to pay a bounty if somebody does this job for me. It's like Uber or Airbnb. This is how much I will pay you if you do this job. And then all these nodes just run along and they get to work and they do the thing. And then we go and check their work. And all the nodes check each other's work. And they audit the code using the audit script that you provide. And at the end, some of them get a reward, and the rest of them get kicked out, and they don't get to play anymore. And we ignore all the data they created. This is a thing we call gradual consensus that we invented. But it's really not actually a consensus system. It's just kind of an open framework, and you're welcome to steal all of our code because we just want this to happen faster. We're having a lot of fun with it. Our team's about 30 people, 25 of them are engineers, so we just hack. Luckily, we do have two awesome graphic designers in Colombia, so they've been showing us around. If anybody wants to tour downtown later, we've been finding lots of great spots. So what is inside of this thing? When you use a Koi task, you get to write, remember that 13 million developer population? Anybody remember what language they were writing? JavaScript. Also, all of the proof libraries that everybody wrote in 2017 until now are also all JavaScript compatible. So when you write one of these little tasks, you get to use all of those NPM libraries. At the moment, I think there's something like 50 million NPM libraries. And you can just, boop, now they're in your code. And when somebody goes to audit them, they pull the same library, and they audit the results. So it's really, really efficient. The cool thing about this is that we also implemented key storage for 5 major networks. So at the moment, you can get these 45,000 Koi nodes to interact with 5 major blockchains. You can also get them to store things onto Filecoin, and you can get them to get API keys for free tier services. So if you want them to scrape Twitter, you can go and get them to scrape Twitter, and you get 1,000 calls a day per node. So now we can DDoS Twitter. That's kind of fun, right? So we can also DDoS the NSA. We can also scrape Google Images. We can do any kind of compute that you want. And each task operator, when they set up the task, they just go get the API key, give them a little instruction booklet. Go to this website, get the API key, put it into your node. And so now you can interact with Web 2 the same way that you do if you're writing a normal server, except that you do it with 45,000 devices, and they all get paid to do it. So this is all kind of cool. We also have a Python and a Go environment in the works. If you're into that kind of stuff, it's a little bit better for some really fancy crypto compute type stuff. And the keys that we support right now, Ethereum, Artweave, Solana, Near, and Filecoin. So very fun stuff. We have a huge amount of grants available. So I mentioned this gradual consensus thing. How does this work? Well, first epoch, every 12 hours. You can shorten this, but the default is 12 hours. So first 12 hours, yada, 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 task nodes do the job. Doop. They submit a result. The result is now stored somewhere. It doesn't have to be on chain either. It can be on Filecoin. It can be on a REST API that the node hosts. Doesn't matter where you want to put it, as long as it's available to the other nodes, because then the rest of the nodes are going to come along and they're going to look at that. And they know how to do this because you gave them a job. You gave them this little script that says, here's how you do this. And then they do it. And they take away the guy's stake. And so you can do really cool stuff with this. To give you an example, we went through the Filecoin Launchpad last month. And in about a week, one of my engineers built a DID framework that does everything that Evernym does. In 1 week, one guy built Evernym in JavaScript. And it all runs on IPFS. It's not on chain. All the data goes into IPFS. It costs literally nothing because IPFS in Filecoin is 17 cents a gigabyte. So you can store these massive Merkle trees in there. And then when you want to audit them, the nodes know how to do that. And you can do this for everything. You can do this for REST APIs. You can do this for WebSockets. You can do this for a Redis cache. So everything, and these might be totally gibberish to the people that aren't technical in here, and I apologize for that, but you can literally build everything you can build in Web 2 because it's a Web 2 environment. And sorry, my voice is totally gone. I was traveling all week. Anyways, so the neat thing about this is that these things also layer on top of each other. So when the second epoch is happening or the audits are happening, there's another first epoch happening. And so it's actually continuous uptime with a whole bunch of devices, and they just announce their IP addresses to each other. We've even built a bunch of caching in front of it, so it's very efficient. Okay, so here's the really cool part. We call this a layer N network. Not a layer 1, not a layer 2, not a layer 0, but a layer N. So if you make a web scraping task, these nodes down here are going to do the work. They're going to use those API keys. Go get all the data from the internet. They're going to pass those up to some aggregator nodes. Those aggregator nodes expose a REST API to a secondary task group that does indexing. They go through all this web scraping data and they make maps of it, which they expose on a REST API, which then a bunch of other nodes can go and use to provide a search function. So this is how we build decentralized Google. Layers and layers and layers of tasks, because that's how Google works. That's how the web works. Everything is layered. You have tons of databases that all talk to each other, that all share data. Ma'am, are you on your phone? Wow. She did not get what I was saying. That's cool. Okay, so here's the cookbook. This is really quick. Proofs, deterministic actions, and time-based intervals. With these 3 items, you can build an entire new internet one that doesn't have corruption, one that is not controlled by a single authority, one that is 100% transparent, where every single thing that happens on it is verifiable, which also happens to provide wealth and pay people in their home with a computer like this, because you don't need a gigacomputer to do web scraping. You don't need a gigacomputer to do a REST API. You don't need a gigacomputer to provide a bridge between two blockchains. You just need to be able to query one blockchain and then query the other one and then make a transaction. This stuff is really, really easy to build. It's so easy that a teenager can do it in JavaScript. So we're gonna take 13 million JavaScript developers. We're already going around right now to all of the code boot camps where they teach people how to build apps. And we're like, hey, you wanna build decentralized Twitter? You wanna DDoS the NSA? Here's a grant. Have fun. Here's all these nodes. So this year we got 45,000 nodes signed up to the network. And so that's just, keeps going. It's really great. Anyways, really quick on the proofs, deterministic actions and stuff like that. Some examples of proofs. You can do random number generator proofs. Those are pretty handy. Everybody already uses those. Another one is our attention tracking game. So that's like an example of building your own proof. So we didn't want this to be a typical rich guy buys a server and then owns the whole network. Because that's how Bitcoin works, that's how Ethereum works. It's basically how every single blockchain works. So instead what we did was we designed a thing called proofs of real traffic. And if you get traffic on your content, you get to mint new tokens. And we actually did that in I think it took us a week and a half because it was all in JavaScript. It works. It's very defensible. It's very hard to hack. Another example, deterministic actions. So transformations and indexing. Transformations are really, really easy to do. So if you have a really big image, like 10 megabytes, 5 megabytes, and you want to show somebody a thumbnail, that's a deterministic action that happens the same way every time. And so the hash of the output file is the same every time. And so you can get nodes to race to put that thumbnail on IPFS and then pin it. So you can pay for your hosting completely in Koi tokens, which you get for attention. So if you want to run a decentralized social media app, you can mine tokens based on attention and then use them to pay for hosting. And you can do it with tons of people involved and your community become your hosting, which is very cool. Final one is time-based stuff. We recently forked Solana as well. So we grabbed a bunch of their code. They seem to be pretty favorable to it. Does anybody here like Solana? No? Yeah, okay, a couple people. The cool thing about Solana is that you have slots every 2 or 3 seconds. In fact, actually, sometimes they're faster than that. We jacked ours up to a 1/10 of a second. So we can do timestamps now. And so if you want a node to check if something happened at a specific time, you can now do that in a decentralized way, which is super cool. Anyways, next thing. Okay, here's the shortcuts really quick. Rather than putting everything onto a blockchain, you can use APIs just like they do in Web 2, which is a very mature technology. It's very stable. There's a lot of good libraries. And you can also use direct communications. So you can use a WebSocket between 2 nodes, which is really fast. No confirmation times. Everything happens quickly. You can also use storage layers instead of blockchains, which means you can store terabytes or petabytes of data. Does anybody know how much data is on Filecoin off the top of your head? Okay, as a show of hands thing, then this will be a fun experiment. Do you think it is more than a gigabyte? Yes, more than a gigabyte on Filecoin. Okay, is it more than a terabyte? Is it more than a petabyte? Yeah, it's more than a petabyte. Is it more than an exabyte? Yes, it is more than an exabyte. It is 27 exabytes of data on Filecoin. And about 1/3 of it is green powered. So it's actually better for the environment than using AWS, and it's cheaper. It's cheaper than AWS, which is incredible. So they actually made a deal with Seagate, and Seagate's just selling them hard drives like crazy. And you can buy a box for 50 grand that has 5 petabytes of storage, and it pays itself off in a year and a half. And so this is bootstrapping storage like we've never seen before. We can fill every house in North America, in Latin America, in Africa. Every place with an internet connection can now be a hosting center, because we can load the data directly from our neighbor instead of loading it from a giant server warehouse. This is basically the difference between Costco and a craft brewery. We all like craft breweries. They're around the corner, they're nice, we like to talk to them, we're supporting our local economy. That is what the internet is going to look like in 10 years. Rather than the internet, or rather than our devices running on the internet will run on our devices. It is not because we want this to happen, because it's socially necessary or because it's necessary to prevent the complete totalitarian overtake of our society. It's going to happen because it's economically more efficient. And it's going to happen in the next 10 years. It's already happening so fast, we don't know what to do with it. And these companies, when they include their community in their hosting, they get to take a gigantic advantage over every company that's ever come before them. Can you imagine if Twitter paid you to host Twitter? So instead of paying to use an app, you get paid to use the app because the app pays you because it needs your hosting. It's good stuff. We're also working on a hardware device. This is the real alpha. It's going to look like a koi fish, and it's going to go in your living room. It's going to basically host the internet from you. They're very cheap to manufacture. We've also made a deal with IBM and Seagate recently, so we're going to be able to make these things for almost nothing. And if you guys sign up on our website on the mailing list, you'll get a sneak peek. Also, if anybody wants to get in on them early, come talk to me afterwards. Last year, we ran a pilot of this. This was not the full-fledged network. This is our V0. We're on V2 now. And we're going to be launching V2 next year. 30 million views from the attention economy that we got for free. We didn't do any marketing. The only marketing I do is I go to these conferences and I try and convince people like you guys to look at what we're doing. Mostly because you're all smart, and I don't want to pay to market to people that aren't smart. That's just a waste of effort. That 30 million views awarded 300,000 koi tokens, which got us 45,000 nodes. That number goes up by about 1,000 every 2 weeks right now. And that's with no marketing. It's completely organic. People, when they start getting paid for these things, when the token is live, are going to love this. We're also working on using stable coins for bounties. So rather than getting paid in some crazy inflationary token, you will get paid in a token that you can spend on groceries or to pay your electrical bill. So anyways, that's kind of the gist of it. Thank you for your attention. If anybody has any questions, we can go through those now.
Incredible. My question is, what is the drawback and limitations? It's too good to be true.
What I was saying at the beginning is that, for the most part, the paradigm of storage, settlement meaning the transaction ordering, right? Storage, settlement, and then communication nodes. If you use Ethereum for what it's designed to be, which is a settlement layer, it's perfect. There are no drawbacks. That's exactly what it's for. You do payment processing. If you use Filecoin for what it's for, which is storing data, there are no drawbacks. And if you use communications nodes to coordinate those resources, it makes everything a lot more efficient. So this isn't something where there's like a drawback. We're not sacrificing anything. We're just coordinating the existing technologies in a way that nobody else has ever tried before. Mainly because I have been trying to figure out how to do it for like 5 years, and we figured it out because a bunch of my engineers are really smart. There's these 2 guys in Pakistan that worked for my consulting company 5 years ago, helping me build websites for people so I could bootstrap our blockchain education company. And they came on board doing web scraping projects for us. And we just hacked this out like 4 years ago, first prototype. And then we've since hired like 22 other engineers and just ramped up things. But we're just testing it out though. So the idea is these incentive models, this audit mechanism thing, you have to test them. You have to try out lots of options. But it's kind of like designing an automobile or any other kind of technology. What we've created so far is the foundation that will allow people to test these things out and try them. And we've created a sandbox where they can do that, where it's basically free. Or actually, rather, where we'll be able to pay them. So there are basically no drawbacks, which is super fun. Does that seem reasonable?
I was thinking more in computer power. Yeah, exactly.
So that's the interesting part about doing it this way. These tasks run on different devices. So if you need tasks that have if you need your task nodes to have a GPU, they're only going to run on devices that have a GPU because nobody else is going to be able to compete in the task pool, and they're going to get audited for not doing the job correctly. So you say, when you give out the task, you say, I'm looking for nodes that have a GPU only, and these are the specs I need. And if they don't have those specs, they won't be able to run the task, they'll get audited, they'll lose their stake. So you're kind of looking for the right people. If all you need is web scraping, you can do that on one of these. Because this can go scrape the internet. That's very easy to do. Similarly, bridging can run on a smartphone. A lot of different types of REST APIs can also run on these, because you can actually put them behind a cache. And so if all you're doing with your REST API is hosting a list of NFTs, you can definitely put that on a smartphone. As long as there's enough caching. But yeah, I see your point though, for sure. Any other questions? Did anybody else understand everything I said, or did we just go way too fast through that? Sorry. Yeah. What do you not understand?
I came in halfway through, so I got dunked right into the very technical aspect of it. But I'm going to read more. So.
Cool. Sounds like we're out of questions, so thank you all for your patience and for your attention. This is super fun. Do you have a question? No? Cool. Lovely. If anybody has further thoughts on this, these are my socials. We have a Discord. The docs portal is there. And our blog often has fun posts that we use to discredit people like Jeff Bezos and try to slander the traditional internet. So lots of fun stuff there. Thank you again. Have a great day.